سلام علیکم عزیزانم. گرام وڵاتانە تەواوکردنی بابەتی پێشوو. ئەگەر بەبیرتان بێ last time I have explained the boiling point elevation and vapor pressure lowering. Today we will take the freezing point depression. Okay, the second corrugative property. I know دەزانم یعنی هەندێک زاران لەو چاپتەرەی هەندێک بابەتی باس دەدەن but take it easy, okay? Because I know what's the best. Okay, freezing point depression. Let me open a white page. Freezing point depression, like the boiling point, it has two different rules. Actually, the rules are mostly similar. We only change letter of F into B or B into F. B which stands for the boiling and F it stands for the freezing. Okay, look, first of all, freezing point depression is symbolized by delta TF, which is always negative. Remember, it must be a negative value always. What is delta TF? Freezing point depression. Okay. Delta TF equals to freezing point of solution minus freezing point of pure solvent. Very good. Look, in there we have studied the boiling point as the boiling point elevation equals to the boiling point of solution minus boiling point of pure solvent. But now it's a freezing point. And the next rule is delta TF, again, equals to KF times molality. تماشاك تقريبا وكويكن. KF times molality. Let's identify all the variables here. First of all, the arithmetic signs. This is or the unit of measurement. This is Celsius, Celsius degree, and for this one also Celsius degree. Molality is measured by small m or mole per kilogram. Okay, so if we calculate KF equals to delta TF over molality. So the unit will be Celsius over molality. This is the unit of KF. Good. About the names, try to write down the following names for delta TF. Okay, I'm going to say the names and you have to write the names. Okay, the first one, delta TF is the freezing point depression. Okay, I'll give you enough time. Write this name, freezing point depression, or change in freezing point. Freezing point depression, change in freezing point. And the third name is freezing below the normal freezing point. Okay, once you see something like this in any question, a solution that freezes of 0.2 Celsius below the normal freezing point. The number must be delta TF, and it must be negative always. Even if it's given by a positive value, you should write a negative front of the value of delta TF. It must be a negative always, because you know, depression, it means decreasing. Any decreasing in anything, the change sign will be negative. Okay, so I'll repeat all the names for delta TF. The first one, freezing point depression. The second one, change in freezing point. The third one, freezing below the normal freezing point. About the KF, this is called molar freezing point constant. Molar freezing point constant. It's always for the solvent. It's for the solvent, my dear. Be careful. Okay? Molar freezing point constant is for the solvent. Well, if the solvent is H2O, so assume that the solvent is H2O. If we use H2O as a solvent, so two things must be memorized. Okay, the first one, freezing point of pure solvent is 0, because you know water freezes at 0 Celsius degree. You know this. Okay, this is a very classic information. Good. And KF of water is negative 1.86. Okay, so if the solvent is water, Freezing point of solvent is 0 Celsius, and Kf is negative 1.86 Celsius over molality. So let's have some questions, or let's read the definitions. Okay, the first definition. Look, let's transfer or let's convert the rule, this rule, to the definition of the delta Tf, explanation of delta Tf. In math, we call the subtraction as the difference, right? The difference. Look, delta T, freezing point depression, which is symbolized by delta Tf, and it's a negative value always. It's the difference between the freezing point of pure solvent, and solution. Good? It's easy. And solution of non-electrolyte in that solvent. Okay, the next part we'll get back to this. About the Kf definition, stay with me please. This is really, really sensitive definition in the book. Kf, molar freezing point constant. Look, which is symbolized by Kf. The rule is delta Tf equals to Kf times molality. Okay, I have a question, my dear. Stay with me. How to get Kf and delta Tf equal to each other, or how to have the same value for both Kf and delta Tf. If molality is 1, once we have molar concentration of 1, then both delta Tf and Kf are equal. Okay, look. Kf is the freezing point depression. What is the freezing point depression? Delta Tf. This is really strange. Look, Kf is delta Tf. How? Kf is delta Tf. It means molality must be 1, right? Of the solvent in 1 molar concentration. So this is the most important part in this explanation. So the concentration must be 1 molar. Be careful, my dear. Okay? Good. And at the same time, the solute must be non-electrolyte. If I say this is electrolyte, so everything will be changed. The definition will be wrong. So be careful. The 2 important points in this definition is, first, the concentration must be 1 molar, and the solute must be non-electrolyte. Okay, let's solve some questions. As I said, I have explained all the following features just now. Okay, this question. What is the freezing point depression? Good. What is the freezing point depression? Okay. What's the freezing point depression for the third time? Delta Tf is what? Of water in a solution of 17.1 gram of sucrose in 200 grams of H2O. Solute in solvent. So this is the solute. Mister, I remember last time you have said solute must be given by mole. If not, you need to have some conversion. Okay? So this is in grams. We should turn this number into the mole number. How about this? 200 grams of H2O. This is the solvent. Okay. Solvent must be in kilogram. So how to do this? Okay, it's very easy. So now let's have the following conversions first of all, without reading the question completely. So solid must be in grams, okay? In mole, I mean. Mole equals to mass over molar mass. Since the mass is 17.1 and the molar mass of sucrose, 342.35 equals to 0.05 mole. The great calculator is here, okay? Look, 0.05 mole. This is the mole number. How about this? What to do with this? It must be converted into kilogram. Okay, kilogram equals to gram divided by 1,000. Okay, the gram is 200, 1,000 is 1,000, and it will be 1,000, and it will remain as the 1,000 for for the end of the year, like the one that I say something that looks like this. Okay. دەزانم چێتی دەگا لە قسەی. 200 divided by 1000 equals to 0.2 kilograms. Now kilogram and mole number are both ready. We will use both to calculate molality. So molality equals to mole over kilogram. So the mole number is known, which is 0.05 divided by 0.2 is equal to, I think, 0.25 molar, if I'm not mistaken. 0.25 molar. Okay, yeah, correct. Then, what is the actual freezing point? What I mean by the actual? Wait for the next lesson. I'll explain what I mean by the actual, practical, theoretical, experimental results. Stay focused. Okay. But what is the freezing point of solution? So let's have the rule that contains freezing point of solution. Delta TF equals to FP of solution minus freezing point of pure solvent. Nice. Okay. You need to calculate this guy here, okay? But we don't have delta TF. How about the freezing point of pure solvent? Okay, since the solvent is water, so this is 0. But how to get delta TF? There's another formula. Use the second rule. Delta TF equals to KF times molality. So KF is negative 1.86 because the solvent is water, and then times molality is 0.25. So equals to negative 0.465 Celsius degree. This is the value of delta TF. Delta TF, then substitute this here, you'll get the answer. Okay, look. Negative 0.465 equals to FP of solution minus 0. So it will stay the same. Anything minus 0 will stay the same. Right? Okay? Very easy. I think nothing at all. Let's get to the next question. This one. This one. Okay. Be careful with this. If 0.5 mole of non-electrolyte, the solid is non-electrolyte, very good, okay, is dissolved in 500 grams of ether. Solute dissolved in solvent. So this time we have something rather than water as the solvent. Okay, but you know something is really wonderful with this question. The solid is given by mole number, and the solvent can be turned into kilogram very easily to calculate molality. So let's have the following conversions right now here. They're very easy, really. So mole is equal to 0.5 mole. Okay, no problem. And the kilogram equals to grams divided by 1,000. So 500 divided by 1,000 equals to 0.5 kg. So now molality equals to mole over kilogram equals to mole is 0.5, kilogram is 0.5. Use your calculator and tell me. I'm waiting for the result. 0.5 divided by 0.5 is 1, okay? So 1, we have the molality. Now molality is 1 mole over kilogram. Okay, this is the molality. So the question say, look, say, what is the freezing point of solution? Freezing point of solution again. Let's write the formula that contains freezing point of solution very easily. So delta TF equals to freezing point of solution minus freezing point of the solvent. Good. And the other rule is delta TF equals to KF times molality. Mister, we have something as a solvent instead of water, which is ether. So how about the freezing point of the solvent? Is that 0 again? No, it must be given. Look, freezing point of ether is negative 116.6 Celsius. This is freezing point of solvent. Very well. And how about the Kf? Is it okay if I use negative 1.86 still? No, it must be given. Look, this is given also. Wonderful. So let's substitute all the numbers. You'll get the right answer. First, to calculate the freezing point of solution, we need to have this one, which is given. Yeah, this is equals to negative 116.6. Nice. How about this one? Delta TF. We don't have delta TF. So let's calculate delta TF here, then substitute delta TF from the second one to the first one. So delta TF, I don't know what color. Okay, equals to different color, no problem. Kf is negative 1.79 times molar concentration, which is 1. So delta TF equals to negative 1.79 Celsius degree. This is the delta TF's value. Substitute this to here. Okay, negative 1.79 equals to FP of solution minus freezing point of the solvent, which is negative 116.6. Good. It will be plus, transferred, it will be negative. So FP of solution equals to negative 1.79 minus 116.6. Use your calculator, you'll get the right answer by Celsius degree. That's all. It's very easy again. Another question. Okay, a water solution containing an unknown quantity of non-electrolyte. Okay, the solid is non-electrolyte. Is found to have a freezing point of negative 0.23 Celsius. What is the molar concentration? Look, a water solution is found to have freezing point of this. It means this is the freezing point of solution. A solution is found to have this freezing point. So this is the freezing point of solution. Something that has been dissolved in water has this freezing point. So this is FP of solution. Good. What is the molar concentration? So you should know the both rules for the freezing point. The first one, okay, I'll start from the one that contains molality. Delta TF equals to Kf times molality. Cool. We need to find out, to take out molality. But to do this, we need to have Kf. Yeah, we have Kf negative 1.86 because the solvent is water. Okay, you should memorize this. Remember? Good. How about delta TF? We don't have. Let's get delta TF here. Delta TF equals to freezing point of solution minus freezing point of solvent. Very easily. Okay, delta TF equals to freezing point of solution is negative 0.23 minus freezing point of the solvent. Since the solvent is water, so this is 0. Anything minus 0 will be the same. So delta TF equals to negative 0.23. Bring this to here. Okay, now negative 0.23 equals to Kf is negative 1.86 times molality. Remember, the result of molality must be positive always. The following things are positive always. Molality, molarity, mole number, mass, volume. These are positive values always. This is impossible to get any by negative. Be careful, please. Okay. So use your calculator, you'll get the right answer. Another question. Remember, I have explained everything about the boiling point and the math problem questions also. So now, stay with me. I have explained all of these questions last time, if you remember, but this is for today. This is the right time to explain this. Be careful, my dear. Look, let me tell you something. This is a connection. This is a connection between the boiling point and freezing point together. Okay? Look, let's read the question together. An aqueous solution of glucose boils at 100.2 Celsius degree, right? This is the boiling point of solution. Calculate the freezing point of this solution. From the boiling point of solution, we need to calculate freezing point of solution. Is there any rule that combines both together? No. We have no rule that combines both together. This is impossible. But we can start from something. We can turn this into something that is useful for this. So my recommendation is this. All the questions that is a linking, a connection between all the question that's a connection or linking between the boiling point and freezing point, first try to convert the given into molality, the molality into the unknown. So look, there is no way to start from this directly to the boiling to the freezing point or vice versa. First, we have to convert this number into molality, then molality into the other thing, which is the freezing point. Okay? Good? Got it? Well, let's solve this. In my opinion, please try to divide the paper by 2. Divide the paper by 2. Take out molality from the given, then use it for the unknown. Okay? Those questions that contain boiling point and freezing point always start from the given. Okay? Convert the given number to the molality, then bring molality to the unknown. Okay? So let's start from this. Here we have freezing point of solution. So write a boiling point of solution. Write both formulas for the boiling point. The first one, delta TB equals to boiling point of solution minus boiling point of solvent. And the other one is delta TB equals to KB, good? KB times molality. As I say, please, first try to find out molality from the given information. Then bring molality to the unknown. I mean the calculation of the unknown. So how to calculate this? To do this, we need to have KB. Okay, we know KB. This is 0.51. How about delta TB? We don't have. So let's take out molality here. Good. Delta TB equals to, boiling point of solution is 100.102 minus boiling point of solvent. Since the solvent is water, so the boiling point is 100 for the solvent. 100.102 minus 100 Celsius degree equals to 0.102 Celsius. This is the delta TB, the boiling point elevation. Now substitute this here. 0.102 equals to 0.51 times molality. We need this. So divide both sides by 0.51. 0.51. Now molality equals to 0.2 molar. Very easily. Okay. Now we can bring molality to here to calculate freezing point of solution. Okay. Now let's use the calculated molality in the calculation of the freezing point of solution. It's time for the unknown. Write both formulas for the unknown. Delta TF, I will use different color. کاکا من بڕک مشکلەمێ لە ڕەنگوشتی هەر ئیشی پیاوان هەمی ئەو هافشەیە لە بۆ ڕەنگوشتی بەعام حەزمان زۆر لە ڕەنگۆڕینی نییە ڕەش و تاو لەکنەما father of all the other colors okay delta TF equals to freezing point of solution minus freezing point of the solvent good and the other one is delta TF equals to Kf times molality. So we need to find out, we need to calculate the freezing point of the solution. But to do this, freezing point of the solvent is 0. We don't have delta Tf. So try to calculate delta Tf here. Delta Tf equals to, Kf is negative 1.86 times the molality is 0.2. So equals to negative 0.372. I think, let me check the result. Yeah, it's here, okay? Negative 0.372 Celsius degree. Very good. This is the value of delta TF. Now bring this to here. So delta TF is negative 0.372 equals to freezing point of solution, which is the unknown, minus freezing point of the solvent is 0. So you'll get the same number. Anything minus or subtracted by 0 will stay the same because 0 has no value. I mean, doesn't change. It cannot change anything. So let me repeat all the steps together. Look, this is the boiling point as a given information, and the question said calculate the freezing point. How to do this? First, try to start from the given. Convert given into molality. Okay? Once you find out molality, then bring it in the calculation of the unknown. Okay? It's very easy. That means we will use all the rules for the freezing point and the boiling point. باوەڕتە دەتوانەوە پرسیارە ئاسان کەم و بە دوو ستێپی حەل بکەم. بەڵام زۆر توش کێشەی دەبێت لە وزاری. دەزانم ئەوەیان this is the long way, but you know, I'm just following the book. In the book, it's like this. Because, you know, if you use something like the following rules, like a shortcut rule, okay, now, then I will give you some questions that you will lose your mark. Remember, even if I use a shortcut way, so the shortcut will be used only for the water-based solutions. If I change the solvent into something rather than water, then everything will be destroyed. So please, don't use the fast way, okay? This is the longer way, but safest. This is a safer way, please. This is the more safe way. Follow my recommendation, my dear. ڕێگای خێرای بەکارمێنە. باوەڕکە بیکێ ڕێگای خێرا دەتوانم پرسیارێکت دەمێ بە حەیات پێت حەل نەبێ. زۆر ڕێگای خێرای بەکارمێنە. باشە بابی من؟ تەریقی کتابی بڕۆ، یعنی یەک شتت پێ بڵێم ها. ئەو شتەی لە من وەرگرە وەکو ئەزیزەچ خۆت. تەماشاکە. وا دانیام ڕێگایەکی خێرام دانایە لێرە و پرسیارەی بە دوو هەنگاویش کار دەکەم. دەڵێ ماوە ڕێگایە من دام نایە و تەواو هەموو پرسیارێک پێ حەل دەبی. ئەو کتابەیە کە پێی دەڵێن modern chemistry, okay, has been written by 4 different great scientists, great chemists. One of them is, I think his name is Hogr, yeah, and Raymond. Hogr and Raymond. ئەو دوانە دوو لە گەورەترین عالمەکانی کیمیانی لە کەنەدا و لە ئەمریکای. پێت وایە ئەوانە بە مێشتیان هاتیە ئەو پرسیارەیە بە یەک هەنگاویشی کار بکەن، بەس بە مێشتی من داهاتیە. سۆ دڵنیات دەکەمەوە لەوەی کاتێک تەریقەکەت لە بۆ دادەنێن بە خۆم دام نایە، هەندێک پرسیارەیە ئەو تەریقەی تێک و پێک دەشێنی. هەرگیز never use the fast way. Okay? Let's keep going. This is another question with the same idea. Look. Find the boiling point of an aqueous solution. Boiling point. Okay, let me hide the solution first. The color is white. It's good. Okay. Find, no, find still. Let me delete this. Then start from the first. Okay. Calculate the boiling point of an aqueous solution. Boiling point of solution. This is the unknown. Calculate boiling point of solution. containing a non-electrolyte that freezes at this Celsius degree. Calculate boiling point of a solution that freezes at this. It means this is the freezing point of solution. Freezing point of solution. Wonderful. Freezing point of solution. Great. Good idea. Look. So is there any way to combine both boiling point and freezing point together? No. You should start from the given information, which is the freezing point of solution. So turn this into the molality. After this, try to convert molality into the boiling point of solution. Let me show you the, okay, I only show the steps, okay? I don't calculate the results. Look, freezing point of solution. So we need to find out the molality. Delta TF equals to KF times molality. You need this. To do this, we need to have KF. Yeah, we have it, which is negative 1.86, but we don't have delta TF. So bring delta TF here. Delta TF equals to FP of solution minus, okay, FP of solution minus, FP of solvent. Good. FP of solution, which is given, is negative 6.51 minus FP of solvent. Since the solution is the aqueous, it means water-based solution. The solvent is water, so this is 0. Delta TF equals to negative 6.51 Celsius. So use this here to get this value. Once you calculate molality, bring the molality to here, okay? Calculate delta TB. Delta TB equals to KB times molality. Substitute molality here. And okay, in there it has been calculated. KB is 0.51. Calculate delta TB. Then bring delta TB to here. Delta TB equals to boiling point of solution minus boiling point of solvent. Good? Delta TB has been calculated here. Boiling point of solution is the unknown. Boiling point of solvent, as I said, water is used. So this is 100 Celsius degree. You're going to get this answer very easily. Okay? So my dear, stay focused. Stay focused. زور بجوانی تركيز كلبو for the next lesson. Because I will explain that time. I will explain the most complicated topic in Great of Chemistry, really. For me, this is the most disturbing thing, which is the differentiate between the practical and theoretical results. But for you, it will be very easy. So stay with me. That time, bring your pen and, you need a white paper to write the notes with me. Inshallah, زور باش دبی. حتی اوقاتی به خواتان دست بیرم. خواتان لەگەڵ. همتان خوش دبی. See you.